For months, astronomers assured the public that 3I-ATLAS would be nothing more than a harmless visitor from the deep, a bright streak across the black, a distant comet skimming past Mars before vanishing forever into interstellar space. At first, that prediction seemed certain. Every calculation, every orbital model, every projection pointed to a peaceful flyby, but the cosmos rarely off comfort without reason. And now, the numbers have changed. When the object was first spotted on July 1st, it looked ordinary enough. A moving blur with luminous tail, its coma glowing faintly against the void. Nothing unusual except for its speed, nearly 87 kilometers per second relative to the Sun. At that velocity, it could cross the distance between Earth and the Moon in under 80 minutes. For a moment, astronomers were thrilled. Another interstellar interloper, the third ever recorded, following in the footsteps of Oumuamua and Borisov, another messenger from the unknown. But within days, something began to feel wrong. Comets, by their nature, are unpredictable. They tumble, spin, and shed ice and dust as they near the Sun. Yet even their chaos follows a certain rhythm, a predictable curve of energy and decay. 3I-ATLAS did not follow that rhythm. Instead of slowing as it approached the inner solar system, it began to accelerate. Subtly at first, then consistently, as if it were finding its own momentum. The trajectory, once clean and arcing, started to bend inward, ever so slightly tightening toward Mars. The data didn't match physics. It matched intention. At first, the anomaly was dismissed as an error, maybe a dust jet miscalculation, maybe a gravitation assist, but the readings repeated across every observatory that tracked it, from Chile to Hawaii, from Gemini South to the James Webb Space Telescope. The object wasn't drifting, it was steering. Small but deliberate shifts in its course appeared every few hours, as if guided by unseen hands. Scientists compared it to a rock performing orbital ballet. One too precise to be coincidence. Then came the light pulses. Webb's deep field sensors picked up faint but rhythmic flashes emanating from the comet's tail. Weren't random outbursts caused by solar heating or chemical reactions. They were clean, periodic, and perfectly timed, every 17 minutes. The pattern held through 3 consecutive nights. Jets of gas erupting not chaotically, but with mechanical precision, like timed thrusters. A rhythm that repeated with eerie stability, unbroken across hundreds of millions of kilometers. It was the first time any natural object had ever displayed such discipline. And that's when a whisper began to spread among the astronomers monitoring it. This isn't natural. At NASA's Jet Propulsion Laboratory, the early data logs were reanalyzed. The math didn't lie. Each outgassing event produced microbursts of acceleration, not enough to shift an orbit on their own, but collectively enough to alter the course of a planet-crossing trajectory. If these pulses were propulsion, 3I-ATLAS wasn't a comet at all. It was a vehicle, a machine disguised as ice and dust. What unsettled scientists most wasn't just the precision, but the silence. No radio emissions, no detectable communication, no thermal profile indicating an engine or reactor. Whatever force were driving, it operated invisibly, within the laws of physics, but beyond our understanding of them. As one observer quietly put it, it's hiding in plain sight. Within a week, the object's coma brightened dramatically, doubling in luminosity. Spectral analysis revealed unusual spikes in ultraviolet energy and concentrated carbon dioxide, outgassing far beyond what could be explained by solar heating alone. In effect, it was burning without fuel, shining without reason. Every hour of data made the mystery deeper, and yet, despite the growing unease, the official statements from space agencies remained cautious. No cause for alarm, they said. A remarkable but natural phenomenon. But behind closed doors, the tone shifted from curiosity to quiet panic. The more Webb observed, the stranger it became. The rhythmic gas vents formed symmetrical plumes, firing in opposite directions with surgical precision. Each release adjusted the trajectory fractionally, always toward the same vector, the orbital plane of Mars. And it wasn't random drift. It was alignment, like a ship making course corrections to rendezvous at a preset destination. Still, no one wanted to say it out loud. To call it artificial meant crossing a line that science rarely dared to step over, but data doesn't care about belief. The pulse intervals continued, the course adjustments grew sharper, the trajectory models, once a graceful flyby, now bent alarmingly close the red planet. A few more degrees, and the comet's path would intersect with Mars's orbit itself. By mid-August, the astronomical community was divided. Some still argued for natural explanations, perhaps a rotational resonance or an internal pressure cycle. Others quietly began to test something radical. What if 3I-ATLAS was responding to observation? As the number of telescopes tracking it increased, minor variations in its emission rhythm appeared. Not random noise, but reactions. As if it somehow knew it was being watched. The eerie thought spread like wildfire through late-night labs and encrypted message threads. It aware. Soon, even the skeptics began to feel the weight of the data. The object wasn't following any known orbital mechanics. It seemed to self-correct in defiance of gravitational drift. The outgassing was erratic. It was synchronized, like a signal repeating across cosmic distances. For every adjustment Mars made in its orbit, 3I-ATLAS compensated, as if locked onto its position. The Webb telescope captured one final observation that would change everything. Deep within the halo of dust surrounding the object, an ultraviolet pattern flickered. A faint triangular symmetry that repeated across its tail, invisible to the naked eye but unmistakable in spectral mapping. 3 glowing points pulsing in sync with the 17-minute rhythm arranged in perfect geometric precision. No natural process could account for it. And that's when the last certainty collapsed. 3I-ATLAS was not a random traveler from the void. It was following something, perhaps a command, perhaps a destination. But whatever it was, it moved with intent. Every number, every light curve, every pulse whispered the same chilling truth. This object was steering, watching, calculating, and Mars was directly in its path. No one knew what it meant, not yet. But one thing was certain, the story of a harmless interstellar flyby had ended. The story of something else, something intelligent, had just begun. Within days, the predictions changed again. What was once a safe flyby had narrowed to a near miss. The new models showed 3I-ATLAS skimming past Mars at less than 2 million kilometers, close enough for its gravitational wake to disturb the planet's thin atmosphere. Still, it wasn't enough to cause alarm, at least not officially. But the astronomers who saw the updated trajectory knew something was wrong. The course wasn't decaying naturally. It was tightening, as if drawn by an invisible thread. Each new observation revealed minor but precise adjustments in its velocity. Tiny bursts of acceleration appeared every 17 minutes, matching the rhythmic gas pulses recorded earlier. It was the same pattern, but now each pulse was measurable, roughly 10 meters per second of additional thrust. Over time, those increments added up. The cumulative velocity change was enough to shift its orbit by tens of thousands of kilometers. That may sound small, but on the cosmic scale, it was the difference between a near miss and a direct hit. At NASA's Jet Propulsion Laboratory, simulations began to paint a grim picture. A slight increase in the current thrust, even by a fraction, could alter the trajectory into a collision course with Mars. And the pulses weren't random anymore, they were coordinated. The timing matched orbital resonances between the comet and the planet, suggesting a level of control no natural body should possess. Whatever was driving those emissions, it was targeting something. The James Webb Space Telescope continued to track the anomaly from its L2 orbit. Webb's instruments detected fluctuations in the tail's ultraviolet spectrum, sharper and more organized than before. It wasn't sublimating like a normal comet, it was venting. Each release was aimed along the orbital plane of Mars. As the data came in, analysts began whispering what no one dared to publish. 3I-ATLAS was navigating. Across the world, other observatories joined the watch. Gemini South, ALMA, the European Southern Observatory, all confirmed the same trajectory updates. The numbers were consistent. The object was closing in. Scientists calculated the probability of impact at less than 1%, then 2, then 4. Within a week, it climbed to 10. The deeper they ran the simulations, the worse it looked. If a single pulse fired at the wrong moment, even slightly, Mars would be in the crosshair. And then came a paper that ignited every newsroom and research lab in the world. Harvard astrophysicist Avi Loeb, known for his work on Oumuamua, released a preprint suggesting that 3I-ATLAS could be an engineered probe, a controlled object using directed gas emissions for propulsion. His paper didn't claim aliens. It simply presented data, velocity irregularities, thrust intervals, and an energy profile inconsistent with natural ice sublimation. The conclusion was cautio but clear. 3I-ATLAS was behaving as if it were under intelligent control. At first, Loeb's claim was met with skepticism, even ridicule. But that skepticism began to fade. Radar data arrived from NASA's Goldstone antennas and the Mars Reconnaissance Orbiter. The reflections from the comet's surface didn't match ice or dust. They bounced back as hard metal echoes, smooth, dense, and structured. These weren't random clumps of rock. They were layered, as though reflecting from panels or internal frameworks. One researcher described the echoes, something built, not born. More anomalies followed. Amateur astronomers using high-exposure imaging began capturing faint green lines radiating from the tail, thin, needle-like beams pointing toward Mars. At first, they were dismissed as image artifacts, but when the same pattern appeared in multiple independent captures across continents, the coincidence vanished. The beams pulsed in sync with the 17-minute intervals, perfectly coordinated with the propulsion rhythm. 3 converging lines of light, all directed at a single destination. Webb confirmed it. Those beams were narrowband emissions of ionized oxygen, structured frequency bands identical to guided ion thrusters, not random outgassing, engineered exhaust. The implications were staggering. If these emissions were controlled, then 3I-ATLAS wasn't a comet at all. It was a craft, a probe, a vehicle, or something beyond either definition, a piece of technology operating with precision and intent, aimed straight at the red planet. By now, every major space agency was involved. The European Space Agency Roscosmos, China's CNSA, Japan's JAXA, all held emergency meetings. Officially, they were discussing planetary defense contingencies, but there was no defense to discuss. The object was too fast, too far, and beyond interception. It wasn't heading toward Earth, but the potential consequences of a Martian impact were enough to trigger panic. Mars was more than just a planet. It was a laboratory, a colony of machines, and the keeper of decades of research. If 3I-ATLAS struck, everything we'd learned there could vanish in seconds. Still, even as fear spread, there was something else. Fascination. Scientists couldn't look away. Every data point hinted at intelligence. The pulse frequency never drifted. The velocity increments followed predictable harmonics. It was as if the object was speaking in mathematics, each adjustment a syllable, each emission a word. Yet for all the apparent communication, there was no radio signal, no visible transmission, only the motion itself. And that motion was closing in on Mars. By the end of September, the probability of impact climbed again, 15%, then 80%. The margin for error shrank. The world's telescopes pivoted to track the final approach, and what they saw defied comprehension. The gas vents on 3I-ATLAS began firing not outward from the Sun, perpendicular to its orbital plane, as if aligning to counter gravitational drift. That kind of compensation required precise calculation, not just navigation, but prediction. The object wasn't reacting to forces, it was anticipating them. Inside mission control rooms, monitors filled with graphs and data lines tracing the object's path. Every pulse, every flare, every minute shift of velocity matched the models Avi Loeb had described his paper. The object's control system, whatever it was, appeared to understand orbital mechanics better than we did. The final update came with chilling clarity. The new projected closest approach, 1.95 millikilometers, a cosmic hair's breadth. And at its current rate of acceleration, one more sustained outburst, one more pulse, would be enough to push it into a direct collision with Mars. The probability of impact had risen to 22%. No one spoke it aloud, but the math was merciless. And yet, in the midst of this rising dread, something else was emerging. A pattern buried in the data, not in the light, but in the timing. The 17-minute intervals weren't arbitrary. They corresponded to Mars's rotational resonance, a period that synchronizes the planet's day-night energy cycles. Each pulse matched a geographic point along Mars's equator, as if the object wasn't just heading for the planet, but communicating with it, marking locations, scanning, or synchronizing. The more we learned, the less we understood. But one conclusion was unavoidable. 3I-ATLAS was not drifting aimlessly through our solar system. It was maneuvering with purpose. And Mars, our silent neighbor, the planet we've studied for decades, had just become its target. The watchers on Earth stared at their screens in disbelief. No one knew what it was, or what it wanted. But every orbit, every pulse, every carefully measured burst whispered the same inescapable truth. Something was coming, and it wasn't coming by accident. If 3I-ATLAS were to strike Mars, the energy released would dwarf every human weapon ever conceived. With an estimated mass of 10 billion tons and a velocity exceeding 57 kilometers per second, the impact would unleash more than 2 million megatons of energy, enough to vaporize entire regions of the Martian crust. The crater alone would stretch over 60 kilometers wide and sink 5 kilometers deep. It would tear open the planet's surface, scattering debris high into orbit and blasting fragments across interplanetary space. Some of it, scientists warned, could even escape Mars's gravity and find its way toward Earth. But it wasn't just about destruction. Mars isn't empty. It's a living archive of human exploration, a library of machines and instruments, each whispering data back to us across the void. The Perseverance rover, the Ingenuity helicopter, the ExoMars orbiter, China's Tianwen-1, even the silent relics of Spirit and Opportunity, all of them would vanish in the first shockwave. Decades research, billions of dollars, and irreplaceable climate records would be wiped from existence in a matter of seconds. Communication networks would go dark. Mars would fall silent again, not for hours, but for decades. And yet, the loss of machines wasn't the true fear. What haunted scientists was the biology. For years, Mars had been the most promising candidate for extraterrestrial life. If not active organisms, then fossilized microbes or molecular traces buried under ice. Subsurface lakes, frozen permafrost, dormant bacteria. If 3I-ATLAS carried anything biological and organic molecules, alien spores, or synthetic matter, an impact wouldn't just destroy, it would mix. The collision would melt kilometers of rock, vaporize ice, and fuse two worlds in a chemical storm. The result would be contamination, panspermia in reverse. Life not spreading from Mars to space, but being delivered to it deliberately. At first, no one wanted to speak that possibility aloud, but the Webb telescope forced conversation. As it scanned 3I-ATLAS with its near-infrared instruments, it found traces that defy every model of cometary chemistry. Synthetic polymers, materials resembling industrial plastics, appeared within the light spectrum. Alongside them were structures matching the reflective pattern of carbon nanotubes, microscopic filaments associated with engineered materials. These compounds don't form in space. They don't emerge from ice or rock. They are made. Within hours, the data was flagged and encrypted. Webb's instruments had seen something impossible, a comet composed partly of manufactured matter. For 48 hours, the information was restricted to internal NASA and ESA networks. Then the leaks began. Anonymous sources from inside the Webb operations team hinted at engineered signatures. Terms like carbon lattice and synthetic composite appeared in late-night message boards, only to vanish minutes later. But the damage was done. The story spread faster than any agency could contain it. In an emergency briefing, representatives from NASA, ESA, and JAXA convened to discuss what could only be described as a classified crisis. Behind closed doors, scientists debated the unthinkable. W3I-ATLAS carrying something. Was it a probe or worse, a delivery system? And if it was, what was its payload? The idea sounded insane, even to the people entertaining it. But the evidence refused to stay quiet. The object wasn't behaving like debris, it was maneuvering. It wasn't random, it was aiming. And if the materials inside were indeed artificial, then the question changed completely. The problem wasn't about stopping it, it was about understanding its purpose. Inside NASA, operations slowed to a crawl. The usual streams of Mars telemetry, the open data from Perseverance, the environmental readings from orbiters, began showing gaps. Routine updates were postponed. Public live streams were quietly taken offline. The agency, normally transparent, went silent. No one knew why. Then 3 words appeared in a leaked internal memo. Impact protocol initiated. No explanation accompanied the phrase. It wasn't a public term, not part of any known planetary defense plan. The only clue came from a whistleblower within the Mission Control Network, who claimed that a series of encrypted signals had been transmitted from Earth-based communication arrays directly toward Mars. Each message was short, heavily encoded, and repeated at fixed intervals. No official statement ever confirmed it, but it raised one terrifying possibility: Earth WW trying to talk to something. If 3I-ATLAS was intelligent or even semi-autonomous, it might be reacting to electromagnetic signatures to directed energy, to the same patterns we use for spacecraft telemetry. By sending signals, we may have been triggering a response. And if those signals were reaching Mars before the object arrived, then the planet itself could be reacting, preparing. It sounded like science fiction. But then the data began to shift again. Webb detected subtle oscillations in the object's emissions, new harmonics layered beneath the 17-minute rhythm. They weren't random, they followed modulation patterns similar to communication waveforms. Every pulse now carried a faint echo, a secondary vibration, as though the primary signal was being reflected, repeated, or answered at the same time. Ground-based observatories recorded strange fluctuations in the Martian atmosphere, small but consistent changes in the ionosphere, as if something was energizing it from within. A soft radio hum began to appear across several deep space channels, repeating at low frequencies. It wasn't coming from the sun. It wasn't interference. It was coming from Mars. By now, fear had become something quieter, heavier. It was no longer about survival or catastrophe. It was about comprehension. Humanity was watching an event it could not explain, could not predict, and could not stop. We were spectators to a conversation between worlds, one we didn't understand and might never control. Within private scientific circles, a theory began to take shape. Maybe 3I-ATLAS wasn't a weapon. Maybe it wasn't coming to destroy. Maybe it was delivering something, not matter, but meaning. A signal encoded in its composition, its movement, its rhythm. A message written in physics itself. And Mars, the planet we had filled with our machines, was the recipient. If that was true, then the danger wasn't just physical impact. It was interaction, contact on a planetary scale. An exchange of information or biology that could alter Mars forever. The scientists had no way of knowing which, and no time to find out. All they could do was watch the numbers tighten, to rhythm continue, and the light grow brighter. And so the world held its breath. The countdown had begun, not toward an explosion, but toward understanding, or perhaps something far worse. When words failed to explain what was happening, scientists turned to numbers. At the SETI Institute, a small group of cryptographers and astrophysicists began studying the raw trajectory data of 3I-ATLAS, not as motion, but as information. The object's path, they realized, wasn't chaotic at all. Every arc, every course correction, every rhythmic pulse followed a repeating pattern. When the timing of those thrusts and the distances between them were converted into binary, the data didn't produce noise. It produced structure, repetition, symmetry. At first, no one wanted to believe it, but after running the data through standard compression algorithms used for deep space communications, something extraordinary appeared. A sequence of intervals that matched atomic numbers: 6, 8, 14, 26, carbon, oxygen, silicon, iron, the very elements that build both life and machines. Between those sequences lay groups of prime numbers repeating like countdowns. The entire flight path of 3I-ATLAS was more than a trajectory. It was transmission, a signal written not in radio or light, but in movement itself. This idea, that motion could be a message, transformed everything. Suddenly, the 17-minute gas pulses weren't propulsion anymore. They were punctuation. Each vent, each thrust, each adjustment was part of a cosmic sentence unfolding in time. A signal sent not to our ears, but to our mathematics. As one SETI researcher put it, it's not talking to us. It's showing us that it knows how to talk. Then came another revelation, this time from the European Space Agency's orbital simulations. When plotted in 3 dimensions over time, the complete path of 3I-ATLAS from its first detection to eye-projected intersection with Mars, formed a spiral. Not random, not a cometary curve, but a perfect logarithmic spiral following Fibonacci ratios. Every segment of its motion fit the golden ratio, the SA geometry found in seashells, hurricanes, and DNA, nature's universal code written across an object that might not be natural at all. This discovery led scientists to examine the surface of Mars itself. The planet's Elysium Basin, one of its oldest and most enigmatic regions, had long puzzled geologists with its strange concentric formations. But when 3I-ATLAS's new trajectory was overlaid onto Martian maps, the alignment was uncanny. Its projected descent path intersected directly above a 3.5-kilometer-wide circular depression at the basin's center. That crater, previously dismissed as a geological oddity, reflected sunlight in rhythmic infrared pulses, regular, consistent, almost like a beacon. And Comet's path seemed to be homing in on it. Coincidence, some said. But in science, coincidence that repeats itself becomes pattern. And the patterns didn't stop there. The Webb telescope, now focused on long-range monitoring, detected something trailing 3I-ATLAS, a faint, perfectly dark silhouette maintaining a constant distance of 0.07 astronomical units behind it. It wasn't dust, and it wasn't gas. It reflected no light, emitted no heat, and ignored every gravitational perturbation. It moved as if tethered by something invisible, following the same rhythm, matching the same pulses. The instruments couldn't define, I only describe it. A shadow without substance, mirroring every move of the main body. For the first time, researchers began to consider that 3I-ATLAS might not be a single object at all, could be a pair, a carrier and a companion, or perhaps a body and its echo. Two elements of one system locked together in purpose. Some speculated the shadow might be an energy field, projection, or even a form of data storage, the way an old magnetic tape carries both signal and imprint. Others whispered about something stranger, something alive in a way we couldn't yet define. But if 3I-ATLAS was transmitting, who or what was meant to receive it? The answer, unsettlingly, might have been waiting for us in history. An independent group of archaeoastronomers began comparing the object's current path to ancient sky records. They searched cuneiform tablets, Mayan calendars, and early Chinese celestial charts, looking for patterns of movement that matched its spiral trajectory. What they found was older than recorded science. Across multiple cultures separated by oceans and centuries, there appeared the same symbol, a winding, descending shape, often called the flame serpent. In every account, it was described as a light from the outer dark, curving near the sun and descending toward the red god, Mars. It wasn't myth, not entirely. The path described matched the orbital parameters of 3I-ATLAS almost perfectly. The Incan stone carvings at Tiwanaku depicted 4 radiant lines emerging from Mars after the serpent's descent, the same pattern modern models predicted for debris dispersion in a Martian impact. In Babylonian star maps, the same curved body was said to return every 54 years, numbers suspiciously close to the orbital resonance now being calculated by modern astronomers. Every alignment, every repetition led to the same realization. Whatever 3I-ATLAS was, it had been seen before, not by telescopes, but by ancestors who recorded the sky with stone and myth. This wasn't its first appearance. It was a cycle, one that humanity had forgotten. Scientists cross-referenced historical planetary positions with 3I-ATLAS's projected orbit. The last time the inner planets occupied the same gravitational resonance during an inbound interstellar object was in 1908, the year of the Tunguska event, the mysterious explosion that flattened forests across Siberia. Before that, similar alignments were recorded in 1854, 1800, and further back into prehistory, each marked by unexplainable celestial phenomena. Now the same geometry was returning, the same Fibonacci ratios, the same orbital harmonics, the same echo through time. As the pattern unfolded, the tone of scientific discussion began to change. No one spoke of come anymore. They spoke of choreography, of design, of something vast enough to use planetary orbits as timing mechanisms and centuries as seconds. 3I-ATLAS was no longer just a rock moving through the void. It was part of a message older than our civilizations, a signal written across the solar system itself, using the language of gravity, light, and motion. And perhaps, somewhere in that golden spiral, buried in the mathematics of its flight, was a question waiting for an answer. Because if motion can be language, then maybe, for the first time in history, the universe wasn't just showing us something. It was speaking directly to us. As the hours passed and 3I-ATLAS drew closer to Mars, the idea of impact began to lose meaning. The data no longer pointed to a simple collision. It was becoming something else, an event that existed between physics and intention, a convergence more than a crash. The patterns coming from the object were no longer consistent with any known spin, thrust, or natural emission. They had evolved into a kind of sequence, recursive and layered, as if the comet had started to sing. The Webb team noticed it first. The 17-minute rhythm had changed. It was now grouped in patterns: 7 pulses, pause, 3 pulses, pause, 13 pulses, and again. The numbers looked random until a mathematician mapped them and recognized the familiar shape. The Fibonacci spiral, nature's perfect proportion. The object wasn't measuring time in seconds anymore. It was measuring growth, memory, and replication, the way life measures itself. Every vent of gas, every fluctuation of light followed this sequence. It wasn't random motion, it W-code, a countdown, but not toward destruction, toward synchronization. The realization spread quietly through the Webb control rooms. The object wasn't just traveling through space, it was aligning with it. Then something happened on Mars. The ExoMars Trace gas orbiter, silent for days, detected a sudden spike of xenon isotopes in the upper atmosphere. The readings made no sense. The composition wasn't being added from above. It was rising from below. Almost simultaneously, seismographs from multiple orbiters registered a deep tremor under Cerberus Fossae, a massive fracture system near Mars's equator. The ground beneath the planet was moving, and the pulses, those same 17-minute intervals, matched perfectly. It was as if Mars was responding. Temperature readings in the subsurface layers rose by 3 degrees Kelvin. Magnetometers began detecting weak but structured magnetic oscillations repeating in exact rhythm with 3I-ATLAS. Not echoes, not random. A call and response across millions of kilometers. One object venting energy in space, another planet beneath it answering back in magnetic song. Scientists struggled for language. Resonance, some said. Feedback, others whispered. But what they all feared to admit was simpler: communication. And then, for the first time in centuries, Olympus Mons, the largest volcano in the solar system, came alive. Infrared satellites registered heat emanating from its base, faint at first, then intensifying. Eruption, no lava, just warmth, as if something beneath the crust had begun to stir. Moments later, a low-frequency signal was detected, so deep it sat below human hearing. Every orbiter caught it. Every receiver confirmed it. The sound wasn't coming from the sky. It was rising from Mars itself when the frequency was visualized as a spectrogram. The image it formed stopped every heart in the room. It was a spiral, a mirror of the same Fibonacci pattern emitted by 3I-ATLAS. The planet wasn't echoing the signal, it was completing it. 2 halves of a single sequence finally connect. As the realization sank in, data analysts discovered something even stranger. A forgotten thermal scan from the Mars Odyssey orbiter, taken 20 years earlier, showed a faint, circular heat signature beneath the surface of Utopia Planitia. Dismissed at the time as noise, when reprocessed with new data, that pattern now matched perfectly with the descending trajectory of 3I-ATLAS. The geometry was exact. It was as if the planet had been waiting, dormant, for this very arrival. And then, something began to move. High-resolution images from the Mars Express orbiter captured subtle patterns forming in the dust plains south of Noctis Labyrinthus. 2 perfect concentric ovals appeared, expanding outward over 4 hours, as if drawn by an invisible hand beneath the surface. When the dust settled, the shape they formed was unmistakable. An eye tilted 23.5 degrees, the same as Earth's axial tilt. An eye looking outward, or perhaps back at us. In that moment, every satellite, every camera, every spectrometer pointed toward Mars detected the same anomaly. a synchronized flash of infrared light from the planet's surface, reflected in E phase with a burst from 3I-ATLAS. Two bodies, one in orbit, one on the ground, pulsing together as one system. The chatter inside Mission Control fell silent. People weren't speaking. They were listening. Then the Webb telescope sent back one final observation before its feed went dark. Inside the tail 3I-ATLAS. Among the volatile gases, scientists detected molecular strands, sequences built from carbon and nitrogen resembling RNA, but arranged in non-biological patterns. Not alive in the way we know life, but encoded for replication. A living algorithm designed to survive vacuum, radiation, and time. It was not just matter, it was message. The strands contained repeating intervals that, when translated through acoustic mapping, produced harmonic tones matching the Mars-based signal. The molecule was responding to sound, to vibration. Life not written in chemistry, but in resonance. A biological language that needed both sender and receiver to exist. By the time the Global Astronomy Network processed the final datasets, it was too late. The alignment had already begun. Mars, Earth, and the Sun formed a straight line through space, and 3I-ATLAS intersected that axis precisely at the moment of solar transit. The golden spiral that had defined its path tightened in completion. Across the solar system, sensors recorded a brief but measurable shift in electromagnetic field strength, a pulse that rippled outward, faint but real. It wasn't an explosion, it was a synchronization. For one brief instant, Mars glowed slightly brighter, then the light faded. 3I-ATLAS was gone. No debris, no fragments, nothing left to track, only silence. In the days that followed, something subtle began to change. The telemetry from Mars returned, but the signals were different, cleaner, stronger, as if the network had been amplified, and embedded the background noise of the transmissions was a repeating tone, 17 minutes apart. The same rhythm that started it all. Some called it a malfunction, others a response. But for those who had watched the whole story unfold, the meaning felt deeper, almost inevitable. Because maybe 3I-ATLAS was never a threat. Maybe it wasn't coming to destroy or to deliver. Maybe it came to awaken, to turn something back on. And perhaps, as that rhythm now echoes faintly through every Mars relay, what we're hearing isn't just a signal from another world, it's the sound of a memory, one written into the fabric of the planets long before we learned to listen. We thought we were watching a comet fall, but maybe, all along, the universe was watching us rise.